In this video, I'll be demonstrating how to do inference for two means with independent samples, like in lesson 13. So here's the example we're going to be using. Researchers gave 40 index cards to a waitress at an Italian restaurant in New Jersey. Before delivering the bill to each customer, the waitress randomly selected a card and wrote on the bill the same message that was printed on the index card. 20 of the cards had the message, "The weather is supposed to be really good tomorrow. I hope you enjoy the day." Another 20 cards contained the message, "The weather is supposed to be not so good tomorrow. I hope you enjoy the day anyway." After the customers left, the waitress recorded the amount of the tip as a percent of the bill before taxes. Is there evidence that the two different messages produce different tips? So first thing we need to look at is writing our hypotheses. In this case, we are looking at two independent groups because we had all these cards and we just randomly assigned which card was going to go to which patron. So the groups themselves are separate from each other. It wasn't the same customers or anything like that. There's no logical pairing between the two groups, meaning that we have these two independent groups. So the appropriate hypotheses are going to be null hypothesis, that the two means are equal. So mean for the good message equals the mean for the bad message. And the alternative hypothesis is going to be that they're not equal. And the reason why we know it's not equal to rather than, greater than, or less than is because of the keyword different up here in the question. So we're interested in seeing if they produce different amounts of tips. So first thing, get the data all into SPSS, and you can see that everything's just stacked on top of each other. So we have all the good weather tip percents and the bad weather tip percents. Now something that's kind of quirky about SPSS is that we can't just start from here and analyze the data. SPSS wants the grouping variable to be coded. So we're going to start by doing an automatic recode. To do that, we go to the transform menu and select automatic recode. That's going to bring up this window. We're going to go ahead and put the variable in that we're trying to recode, which is in this case that weather variable, and then we have to give the new variable, the coded variable, a new name. So I've called mine weather code down here in this box, and then you have to click on the add the new name to complete the process. That's going to tell it up there what that name is going to be, and then you can click on OK, and ta-da, there we have this new variable in our worksheet that is numerically coded and ready to go for our analysis. So now we're ready to do the actual t-test that we want to do here. To do that, we're going to go to the Analyze menu, choose Compare Means, and then choose Independent Samples t-test. Once in there, the dialog box, the top part here, is going to ask for your test variable. So this is asking for the response, or the thing that you actually measured, which in this case is the tip percent. So we'll put that over there. Underneath, we have the grouping variables box down here, and so that's what we want to put in there is that new variable that we've created, that weather code variable. And see, it has these two little question marks there. Now we're going to click on Define Groups, so we can tell it, you know, what the new variable is coded as. So when it was coded, the good was 2 and the bad was called 1, so that's why I put in here as 2 and 1. But really, honestly, it doesn't matter which one you call which. Once you're done with that, there is an option here. If you want to click on the options button over here, it'll let you select what confidence interval percent that you want to have. So the default is 95%. If it asks for a different percentage in your homework problem, then you would want to change it right in here before continuing. So then you're going to hit continue and OK, and you'll get your output there in SPSS. So let's look at what we've got for the output. First of all, the only output that we want to look at is the second row here in the table down below, where it says equal variances not assumed. So you can pretty much just always ignore all that stuff for the equal variances assumed. That's not the correct place to look. So in here, it's going to tell us our test statistic. So this is the t statistic, was equal to 6.274. we can see that we have 37.795 degrees of freedom. Here's our sig two-tailed. That's going to tell us our p-value if we have a two-tailed test. If we have a one-tailed test, then we just have to cut that p-value in half. Then you can see that it gives the mean difference. When the problem's asking for that point estimate of the difference, that's this here. That's the difference in the two means, from the difference in the two sample means. All right, and then we also have our confidence interval on that difference, and we'll come back and talk about that again in just a minute. Okay, back to our original question. Is there evidence that the two different messages produce different tips? So we have our original hypotheses here. Null hypothesis, that the two means are equal. Alternative, that they are not equal to each other. This was a two-sided test, again, because we have the not equal sign here in the alternative hypothesis. So the p-value is going to be equal to that sig two-tailed that we saw in the output, which was 0.000. Now we're going to compare that to alpha. Really, it doesn't matter what level of alpha that we have in this case because our p-value is low, really, really, really low. And when p is low, HO must go, meaning we're going to reject the null hypothesis. When we reject the null hypothesis, that means that we have sufficient evidence that the alternative hypothesis is true. So in this case, that the messages produce different tip amounts. So if you are a waitress or a waiter working at a restaurant, I'm sure you're wondering, how much is the difference? Like, is it worth making a change in what you do, maybe? So to answer that question, we can use the confidence interval. So first of all, looking at the output in SPSS again, if we look at those means, we can see that the mean of our sample for the good weather message was a tip of 22.22%, and the mean for the bad weather messages was 18.19%. So from that we can see that yes, our test told us that the two groups were different, and looking at the means we can see that the good weather message produced a higher percentage of tips than the bad weather one. Now the amount of that is going to be told to us here in our confidence interval. And we would interpret this confidence interval by saying we're 95% confident that the difference in the mean tips for good weather message versus bad weather message is between 2.73% and 5.33%. So if you are a server at a restaurant, you might consider adding a nice little good weather message on the bill when you give back your bill to the patrons, because it might result in you getting a higher tip.